Welcome. Today, question number 82. Question 82, or you can make a note. This is second question on wedge friction. See, this is the last question, last class question. Question is same as last time. See, last time I asked you find the value of least value of P to lift the block up or something like that. That is limiting. Today also same thing. See, it is last time, see, the wedge is moving this way. Now reverse, this way. Find the value of P when the wedge is on the verge of moving to left. See, last time, wedge is moving to right side, block getting, see, when you apply force this way, as the wedge moves to right side, block gets lifted. Today also, when the wedge moves to left side also, block gets lifted. So, the question they can also ask what? Least value of P required to lift the weight. This is the block. See? This is the block. This is the weight. We are not given block. See? Now, in the question, see, last time some extra information given. I told friction coefficient for all this one by words. This time I am giving you this friction coefficient is 0.4. Between the two, that is a block and the wedge, 0.38, and wedge and the base, like ground, horizontal surface is 0.46. Angle changed. See, last time inclined P, today also inclined P. Usually maximum questions, they give horizontal P. Okay, no problem. See, 18 degrees. This is 78 degrees. And this is 16 degrees. Last time it was some other angle. Okay, angles are not required. That you can account when you calculate. Now, for a thorough understanding, question 82 also, I will solve in the same way as last time. So therefore, once I finish 82, one question last time when the wedge moves to right side and block gets lifted. Today, wedge moves to left side and block gets lifted. Next time onwards, I will not explain this much. Briefly I will solve because today also one question. Next class most probably 2 or 3 questions I will solve. Maybe another 4 or 5 questions will be there, I think. If it is 4, 2 plus 2 I will make. If it is 5, I will make 2 plus 3. Why? As we go further and further, the explanation required is lesser. Okay, now, see, before we start the question, do one thing, leave it. This is a question today's class. Previous question 81. I have decided to explain some other way also. See, here. This question is right here. This question is very thoroughly explained last time. But still, see, last time question. So this you see for previous class question. See, this is the block to be lifted. This is the wedge. This weight given. One load given here. One more force given. Usually these 3 are given in question. Otherwise they are not there. Important is this weight and this one. And this question, see, I given, see, weight of wedge is ignored. See, last time class, wedge is of very negligible weight. But this question, see, I told weight of block is 6000 Newton and weight of wedge is 300 Newton. See, very small, but still it is given, so we will consider it. Nothing is there. If weight of wedge given, just put an arrow mark there later when you write free body. Okay, now see correctly. Every concept is throat problem. Every concept is thoroughly explained. So briefly, see now. Always first consider upper side is block. See, this is the block. Actually, this is what not block. This is free body diagram of block. Right that way. Last time, this is free body diagram of wedge. This I will explain last time now. See, correct, clear. Block, last time. This weight, this is the weight of the wedge. See, you write here, this is whatever is the weight of the wedge. Okay, right here, weight of the wedge, weight of the block. Weight of block to be lifted. To be lifted. Then, these 3 in the question given, so right here, see. Otherwise not there. Then, very important, see. This inclined plane, usually so many question paper, they give vertical. But that is next coming questions, see, inclined plane. So this block on the right side is resting on inclined plane. See, this question is resting on left side. And below, this block is resting on the wedge. Okay, now see. Whatever happens, this block will push the plane that way. Therefore, there is a reaction, normal reaction. This is A, this is B. This is normal reaction on A, see, normal reaction on A from that inclined plane. No, not required to waste time. So just put RA over. Suffix, second suffix not required. And this is FF limit for which one? A. A. Equal to what? Equal to whatever is the mu here. See, whatever is the mu here into RA. Into RA. Okay, then here, that ink problem, more ink is there. So, okay, I will remove that one. It looks very ugly now. 1 minute. Okay. My hand also becomes fully inked now. Okay. Where is it? Here. See, here. FF limit for A, suffix not required, equal to what? Equal to whatever mu given here. Last time question, I don't know how much mu. Mu given here into RA. Okay. Suffix, extra suffix not required, RA. And here, this block will, see, this upper block will press the wedge down. So from the wedge, a normal reaction will come. This is normal reaction on the block from where? From the wedge. So it is R for A from B, RAB. This is FF limit for what? This is R, see, it is RAB. Okay. This is FF limit for A from B, AB, equal to what? Equal to mu, whatever is the mu given here, into RAB, into RAB, into RAB. Okay, this is free body for this one. Now, this direction very important. See correctly. This I told, question number 75, nearly half an hour I told. Again I am telling principle, explanation, practical example, then crude method also. This block, see, this block, when it goes to right side, it will rub the block, this wedge, when it goes to right side, it will rub the upper block this way. That is the friction transfer, direct transfer, see, it is this way. Or, one more thing I will tell you, last I will tell, in future I won't tell, see, hold the finger here, hand, lower hand, wedge. As the wedge moves that way, see, it will rub this one, you can make out. Or, as the wedge moves this way, somebody seeing relatively this block A looks like moving to left side. Since it looks like moving to left side, friction is right side. Like driving on the road, side buildings or tree, etc., moving backwards. Or remember, friction for the wedge upper block is in the same in the same way, or what way this wedge is moving here. See, same way rubbing action. Okay. Now further is not required. Then consider free body of which one? Wedge here. Whatever force given right here. Here see, this wedge is resting on a horizontal plane. Therefore, there will be a normal reaction on B from this plane. Suffix is not required. RB. See, here RAB because normal reaction on A from B. Here, normal reaction for B from bottom here. Wedge is moving right side. So, friction is left side. FF limit for B. And here, if this is this way, this wedge will give reaction this way for the block, means block will press it down this way. So, What is the normal force here? Normal force, if it is RAB, this is normal force for B from A, and these two are equal. Because see, this way. And friction limit for B from A, and these two are equal. Why? Equilibrium, see. Okay, over. This is for last class question. Sufficient. I once again explain. Now, in the same way now, I will explain for today's class. Okay, now see, this is extra information I am giving for last class to understand. Okay, now, this question will not take much time. I will not solve like last time because you know by this time. The only thing is free body. Okay, first I will do one thing. See, I will write free body for today's class. So our present question, see, for this question, that is today's class question, what you do is you write a note. Those who feel confusion, take one extra page. That is right here for our information, because later you have to write need free body where you require values, angle, etc. That all second time. First to understand one rough sketch. See here. This way is the block. Angular later it will come this way, and then see, this way it goes, and finally it comes here. Okay, no problem. Then it comes. This is the contact surface. This is the upper block. No ABCD given. So to understand correctly, I will take this as 1. This I will take 2. You make a note here. Okay, let here. You take this as 1. 1 is the block. And this one you take 2. Okay, make a note here. You take 1 here and 2 here. Not given in the question. Instead of AB, just to change the concept. 1, 2. Okay, now, see, here. Leave some space here. Leave some space here. Below, write the free body for the wedge. See, it comes this way. Free body for the wedge. Now, right here. This is free body diagram for the block or weight to be lifted. That is for 1. This is free body diagram for wedge. That is for 2. That is for 2. See, what all you are right? Weight of block 6,000 right here. Somewhere to center of gravity of this one, somewhere, okay. See, we are not taking moment. Therefore, even if you mark here also, answer will come. But somebody will be laughing, 6,000. Then, see, there is a surface here. See, this left side down. There is one more contact surface here. See, here also, see, there is one contact surface here and one more contact surface here. See, now, this will, for this surface, it will push that side. So, there will be a normal reaction here. Normal reaction R for 1 from what? From that inclined plane. So, suffix not required, R1. Then, here, this is resting on the wedge. So, therefore, from the wedge here, there will be a normal reaction here, R. This is normal reaction R for 1 from 2. See, this is 2. From 2, R1, 2. Okay, leave it. This much. Then, as you apply this force, when the wedge moves to left side, the block will get lifted up. Lifted up means friction is down. See, this is last time only I told, friction is down. This is FF limit for 1. For 1, okay, rounding is not required. Okay, 1 is sufficient. FF limit for 1. Okay, sometimes it is better to write once again. FF limit for 1. 1 from this inclined plane. So, suffix not required. And this block, see, when you apply the force this way, this wedge will, what? See, it will rub the block like this, friction. This is FF limit for block 1 from block 2, 1, 2. Or, if you want more clarity, last time I will tell you, see, put the hand here. This is going this way, see. Wedge is going this way. When wedge is going this way, surely this surface is rubbed. See? That's why rubbing force. Or I told you, friction for the contact of block with wedge. When you consider the block is in the same direction as what? That is in the, not actually, wedge is moving horizontally, but inclined, okay. In the same direction, see, or as the inclined plane going to left side. Or lastly, crude method. See, hold here. This is the wedge. It moves this way. See, when the wedge moves this way, somebody will tell from outside, oh, that when this moves left this way, left side, relatively this looks like moves to right side. See, if it moves to right side, friction is left side. Now I think I will stop this one. Next time onwards, if it is not clear, you have to blame yourself only for not properly studying from my explanation. Okay, now, that's all. Come to next free body of 2. See here. This is contact surface. Weight down. So there is a normal reaction. See how is there here? Here there is a normal reaction. R. Where means depends upon the pressure. Somewhere you mark. Normal reaction R for block 2 from the base. Suffix not required. And this wedge is moving left side. So friction is right side. FF limit. This is R2. See, R for 2 from not required. Why? Here R for 2. FF limit for 2. Equal to what? I forgot right here. See, this is equal to whatever is the mu here. See, right here. What is the mu here? This mu is 0.44 times what? R1. Here, this is equal to this contact surface mu is 0.38 equal to 0.38 into R12. And here, FF limit equal to contact mu here is 0.46. It is 0.46 into R2. And lastly, see, for the block from the wedge, an upward reaction means from the block to the wedge, this way reverse will come. See here, this way. This is your force transferred from 1 to 2. It is R12. This is force transferred to 2, TO2, force transferred to TO2, to 2, that is wedge, from 1, R to 1. These two are equal. These two are same. That is equal. You can write equal there. What I wrote earlier. Okay, equal will do. These two are equal. In direction different, see, these two are equal. And see, there is a friction of this way. So relatively, a friction this way. This is friction force for 2, FF limit. FF limit, okay. FF limit for 2 from 1 to 1. Or these two are equal. See, equal. Again, I told you. How many times I have told? These are equal. And equal to coefficient is 0.38. 0.38 into, okay, equal is sufficient. See, when I put equal here, you can see here only 0.38 into R12. Okay, now, or see here, when the wedge is moving this way, correct, friction is this way. Everything is clear. Now, I explained the last time question once again. See, one upper side, one lower side, leave a space in between. Now, if you write this way, seeing this one, you can solve the question. Now, I will rub this one. Someone may ask in a class, sir, if you rub, sir, how will you put next time? This time, how I put it? Did I refer anything? So I will ask them, this time, when I solve the question, did I take a paper with me or book with me? No, sir, but, sir, you knew the concept. Yes, I know the concept. I know the concept. If I know the concept, I will write once again. But next time, I don't have to explain. I can write fast then. Okay, therefore, now we will, what we will do, this question will continue now. First consider free body of 1, see, right here, first free body diagram of 1, that is a block, and then free body diagram of 2, or Y means your unknown is for 2, see here, P. Suppose in question paper, they give this P, next class coming question, a force of 30 kilonewton, something like that, is, or the Newton means, a force of, say, some 13,500 Newton is found to just move the wedge to left side. They may ask you, what is the weight of the block? Then this will become unknown. Oh, then you should do one thing. First start from wedge, where unknown is the outer. See, outer unknown is not, internal unknowns are okay. Main unknown, P. Then we will put weight, W be the weight here. Then you consider this one first, then go that one. Okay, now one more thing is there. In this question, weight of wedge given 300 Newton. Where acting, see, it is almost triangular. Somewhere through CG, centroid, see, this is centroid, center of gravity only. How much weight? Extra weight of 300 Newton mark, if it is given. If it is last time, this weight was negligible, not written. This time in the question given, so write. So mark this 300. Don't measure. See, 1 by 3, 2 by 3 are not required because you are not going to take moment. I will ask, why you cannot take moment means answer is there. Even if you want, you cannot take moment. Reason, you think. Suppose someone will ask, see, you can take moment. Okay, take moment. Okay, let me see. Okay, I will take minus R2 into this distance. What distance? Huh? Oh, you should know the pressure diagram. For pressure diagram, you take moment. Oh, yes, sir. We can't use sigma m0. Okay. Therefore, be careful. You don't bother about these things. Okay. Now, I will save the time. I will make the class little shorter because it is already explained. So, I will do one thing. I will first write here free body of 1, then free body of 2, and continue the question. See, this I am rubbing, but you have got it. You can go backwards in YouTube, or you can take a screenshot, or not screenshot. You write and do it. Always practice is write and solve. Okay. Okay. I changed my mind. I first told I will write everything, explain. No. To give you more confidence. See, I will write freely now, not almost silent class. Silent means what? I may not tell much. See, if you understand the concept and basic principles in every subject for that matter, then how fluently you can solve without confusion, you can make out now. I am not telling I got that capacity, people are knowing about it. Okay, start. I start. Consider free body diagram of 1. 1 means the block, or you can tell weight to be lifted. Weight to be lifted. Everything explained for you. See what I am doing now. Same shape. Oh, sorry, inclined. Okay. This is. Little space problem is there here. Okay, sufficient. Okay. Now see. This is inclined, correct? Oh, okay. This is inclined. I should have moved little this side. Okay, no problem. Okay. Little, I want more space. Okay, no problem. Now, okay. Not to scale, actually 78 degrees. Okay. See here. And remember, as usual I told, now onwards, this is XX, this is YY. I told the reason last time. So therefore, no inclined plane resolution now, direct. See, weight 6,000 Newton. Then one contact, I do one thing, I show by somewhat red color. One contact surface here, one contact surface here. This contact surface. Don't see this side now? Okay, I remove this one now, P. Don't see this side. Okay. Normal reaction for 1, suffix not required. R1. If the should be perpendicular, okay. R1 going up, friction down. This is FF limit for 1, FF limit for 1 equal to mu is 0.4 into R1. Okay, then here, perpendicular. R for 1 from 2. Friction, I told you, this is will rub this way. So friction force is like this. This is all I told for you. FF limit for, this is 1. Okay, 1. Limit for 1 transferred from 2 equal to this contact surface mu is 0.38 times R12. Now regarding angles, everywhere you require angle with horizontal. See, horizontal angle here also, little more length required to understand correctly. Slowly I am doing. R1 with the horizontal, here also we want angle with horizontal. Okay. This angle, see here also, for this also with horizontal, see this angle, 78 degrees. Then this is 78 degrees, it's a perpendicular, will make 12 degrees. See, space problem is there here. Okay. I should resolve also. R1, if that is 78 degrees, this is 12 degrees here. This plane makes 16 degrees. If it is 16 degrees, it is perpendicular, will make 90 minus 16 is 74 degrees. Okay, this is over. Anything else? Normal reaction over, friction over. Okay, now, with respect to 78 degrees, cos, sine. With respect to 12 degrees, see, cos, sine. I should not write it. With respect to 16 degrees, see here, cos, sine. With respect to 74 degrees, cos, sine. Okay, now that's all. Now fluently write. Here I write sigma Fy0 first. Usually sigma Fx, but friction chapter, I put sigma Fy0, take upward positive. Start. I start from this one. Plus R12 sine 74. Now I won't explain. If I explain, someone should protest in the comment section. They should tell, sir, there's a limit for everything. See, you should tell that way. There's a limit for everything. 74 degrees, correct? No, correct. Plus R12 sine, see, plus R12 sine 74 minus 0.38 R12 0.38 R12 sine 16 plus R1 sine 12 plus R1 sine 12, unknown is red color, sine 12 minus 0.4 R1 into sine 78 minus 6000 equal to 0. This is your equation number 1. If any extra force is given here, suppose they give some force here or some force here, account it, over. Now, today I am not simplifying. Simplify this one and get what if you want. Therefore, in terms of R12 and R1, equation 1 will come. Okay. I won't write how much because by high school mathematics. Okay, then sigma fx0, take right side positive. Start from here. Minus R12 cos 74 R12 cos 74 minus 0.38 R12 R12 cos 16 I think. Camera, no problem? No problem, I think. Oh, no problem, okay. Cos 60. Next, same order. Plus R1 cos 12 plus R1 cos 12. Cos 12 is black color. Why red color? R1 to cos 12 minus 0.4 R1. See this way, plus not minus, see, plus R1 to cos 12, sigma fx0, okay, plus 0.4 R1 cos 78 plus 0.4 R12 cos 78. Then this over, nothing else is there, equal to 0. This is equation number 2. Or simplify, you will get in terms of R12 and R1, you will get equation number 2, equal to. Okay, equal you write. You should take all the constant right side, or if you got capacity, you can directly use the calculator. That's what I am doing now. So next, solving your 1 and 2. This 1 and 2 is not that 1 and 2. That much common sense required. This 1 and 2 is not a block. Equation 1 and 2, that much required. You get the value of, you get what is R12 and also what is R1. This answer I will write now in Newtons. Okay, this side, this problem. Okay. Therefore, you will get what is R12 and what is R1. Okay, this I won't waste time here because I should do careful calculation. So many times what happens is some number see my calculator is not in good working condition. Sometimes 0 will not come there. I have to press hard. But I got a technique of checking the answer. So this I am solving myself only. So what I will do, this I will not in front of you. There is nothing technical matter now. Now it has come to high school mathematics. Now I solve and get the answer. I solved and got the answer. I checked it also. Okay, over. See, next step. Remember, now make a note. This R12 and 0.38 R12 are known. These are now known. Very, very important. Okay, now I will rub the board. Full board I will rub now. Not full board. How much space I require I will maintain. See, this free body is not required. 1 minute. Now this is required for me. So I will do one thing now. I will write somewhere here. Next step. See, next step. I can't rub this because I want this space, but actually I can rub this one all. See, I even simplified the equation also. You see there? I even, say per side, I even simplified by calculation, because sometimes what happens is in my calculator, when that cos sign bracket is not operating, wrong answer will come. So say per side, I do not want to make mistake. Even I simplified also. Okay, that is not your problem. Okay, now see correctly. Question over now. See, next. Now see, everything is over. This much over. See, consider free body diagram of 2. 2 means that is wedge. Okay, put the sketch, wedge. Come this way, see. This is the wedge. Okay, little this side. Space problem is there. Okay, this side. Okay. Sufficient. Angle how much it is? 18 degrees. Okay. Okay, wedge. Now, see here. There's a normal reaction. Weight this time in the question, weight of wedge given. How much? 300 Newton. I'll put somewhere here. Somewhere through centroid. 3000 Newton. Okay, I'll put, not to make more clear. This is the weight of the wedge. How much? 300 Newton. Given in the question. Okay, now, there is 2 contact surface here. One contact surface is full base. See, this is contact surface at the base. Here, this is the contact surface up to here only. See, no contact here. Now, here, see. Which side max? It will move this side. Normal reaction. This normal reaction R3, R2. R2. It's unknown. Wedge is moving this way. So, friction is this way. This is FF limit for 2 over equal to directly friction coefficient is 0.46 times R2. 0.46 times R2. R2. Go to that side. Okay. Times R2. Okay. This is the R2. Okay. It's a bigger required. Okay, a little bigger. So that you can understand. FF limit for 2 equal to 0.46 into R2. This all you can eliminate by electronic board R2. This is your R2. Okay. Line of action, don't bother. Where? Then here at 18 degrees unknown force P. P. It makes with the horizontal, later I put here, unknown force P. Then weight of wedge over, very important. I told 1000 times. See, this contact is same as this contact. So here R12 this way means here R12 like this. It is R12, this is R21. This is all told for you, R21. This friction is this way means this friction is this way. See? FF limit for, this is your 2. See, I should write here, this is your 2. FF limit for 2 from 1. From 1. R2, see this is R21. R21. R21 equal to R12. Why? This R12 only. R12 equal to, you know the answer, 8045. Now it is in black color, see, 8045.077, 077 Newton. Then FF limit for 21 is equal to, see, FF limit for 12. It is FF limit for 1, 2. FF limit for 1, 2 equal to how much? 0.38 R12. 0.38 R12. 0.38 R12 equal to, you know the answer. Why? R12 is known. Substitute there. You make a note here. R12 substitute. See here. R12 is how much? 8045.349. 349. So 0.38 into 8045.077. Huh? Oh, 8045.077. Okay. I took half number from here, half number from here. Okay, it happens. 321.129. 320 is equal to answer. This is 321.129. 129. If I divide by how much? If I divide by 0.38, I should get back 845 point. Something wrong. See here. My calculator problem. It is my calculator problem. 8045, it came only 845. My calculator has not taken that 0. 8045.077 into 0.38. 3058, this number. It is known. See, this is known for you. This is known 3058.269. 0.269. So Newton. This also known. 1 minute. Camera problem? No, I think. No camera problem. Okay. Now everything is over. Now regarding the angle. See. Okay, now I can remove everything from the board. See. R12, 8045.077. This is not required. Okay, now this full I can remove. None of them required. This also not required. This also not required. This nothing is required now. Not even the statement. XX is required. There is a reference. This time I am doing one thing. Second one I am not solving. Okay, now see angles. This is the last time I am telling. This question we are not resolving along the plane, inclined plane. We are doing XX, horizontal, vertical. Reason told 100 times earlier. So for every force you want angle. See here. This is pure horizontal, pure vertical. For this force, the angle with horizontal is 16 degrees. Therefore here cos and sine for with respect to 16 degrees. If that is 16 degrees, see here, this angle is 16 means 74 degrees. Therefore, with respect to 74, see, sine cos here. P is like this. The angle with horizontal is 18 degrees. So, cos sine over. Now, nothing is required. I will write equation now. Okay, start. Sigma Fy0 take upward positive. Start. First start from P. Minus P sine 18 minus P into sine 18 sin 18 plus R2 minus 8045. R2 is a red color. Okay, R2 is red color, unknown. Minus 8045.077 force into sine 74. Now I cannot explain everything. Sine 74, then see, this has got cos and sine plus 3058.269 into sine of, see, for this force angle is 16 degrees, sine 16, chance of making mistake, weight of wedge is there, minus 300. If they tell weight of wedge is to be neglected, or in the question, if the weight is not given, understood, weight of wedge is ignored, don't write 300, put 0, equal to 0. Equal to 0, say equation number 1, double round 1. Okay, correct answer. See, minus P sine 18 plus R2 minus 8045.077 into sine 74 plus 3058.269 into sine 16. Okay, everything is over 0. Then sigma fx0, take right side positive, minus P cos 18 minus P into cos 18 minus P cos 18. Last time question, it was this way. Not get it. Minus P cos 18. This is not there. Plus 0.46 R2. 0.46 R2. This over, this over, this is not there. This is also not there. Then plus, I am telling slowly for your benefit. I don't require this much effort. I can put, by this time, I can put write it 100 times. Not 100 times, 4 or 5 times. Okay. Plus 8045. Someone will take, right, sir, then 0.077 into cos 74. This component over. Lastly, where is the here? Plus 3058.269 into cos 16 equal to 0. You call this as equation number 2, double round. Okay, check once again. Minus P cos 18 plus 0.46 R2 plus 8045.077 cos 74 plus y, both are right side, plus 3058.269 into cos 16 equals 0. Now, solving your 1, rounded 1 and that 2, red color is not required, you will get the value of P. P will come in Newton. And also you will get the value of R2. If you want, I can write. But actually, this is the answer. See, this is our answer. Our required answer. Required answer. Okay. Today, I decided not to find because, see, moment of the chapter, almost 90% questions, or not 90, more than 90% questions, I wrote all the expressions. Finally, full numbers. Then I used to tell you, now you calculate. If you want to check the answer, you check with your friends who are solving. Those people who are interested like you. Find somebody. People will be there. Mutually check it. Or, since I am writing everything, answer is not required. See, whenever I write the expression completely, answer is not required. But whenever I give direct answer, suppose I tell in the class, see, you will get, see, without writing this equation, I will tell, I can calculate using calculator. If I operate calculator here and tell, see, P should come this much answer. Then you require, why? Then, see, then you have to write, because how you know you are writing correctly? Whenever direct answer given by me, you should calculate and check the answer. You should get the same answer. Whenever step by step systematically all values are written here, only calculator part is pending, then answer not required. I will tell an example. In offline class, see, usually 90, not 90, more than, in Bangalore, more than 95% people who used to come to me, even now also, they know local language Kannada. Sir, they will ask in Kannada, sir, answer ಎಷ್ಟು? I will tell, ಯಾಕೆ ಬೇಕು? ಪೂಜೆ ಮಾಡ್ತೀರಾ ಆನ್ಸರ್ಗೆ? What? Hindi I will tell. Sir, कितना आंसर? क्या? क्यों रिक्वायर्ड? क्या उसका पूजा करोगे? Are you worshipping that answer? No, sir. Then it is there. See, do you think, so for exam what to do? Exam, What, in examination, same question they are giving? No, sir. Oh, yes, sir. Got it, sir. Steps are more important. Here, answer is not required. You write whatever you got, you write the answer. See, this I will do in future also. But remember, strength of materials or structure analysis, this will not happen much because for me, see here, to get the answer, I have to struggle now. Again, take my calculator, slowly calculate. So I am also a human being. See, I should not waste my time. People will agree. Okay, but there I will give the answer because so many questions there, I don't want to tell you, especially in structural analysis. There are or even strength of materials and structure analysis, both determinate, intermediate, deflections, and then arches, cable, ILD. So many chapters are the MD method, SD method, Carney's method, strain energy method, unit load method, constraint deformation method, etc. So many places you do not know. What I will do is, if you want the answer, I can take calculator. This should be the answer. Some will tell, sir, yesterday's question, sir, I took 45 minutes to get the answer. Yes, so what? Sir, but you gave the answer in only 10 seconds. That is difference between me and you. Okay, sir, got it. Sir, tell the trick. I will tell them. Tell the trick. This trick is not a trick. It is by subject knowledge. If I tell something like that for you, whatever you know, you will forget that also. Then no, sir, we will do. You sincerely solve. Slowly, day by day, improve your knowledge. One fine day, you become like me. I will tell, sir, thank you, you are going. Why? Become like me. Why not possible? I am also a human being, they are also human being. I got brain thinking power, they also got brain thinking power. It is utilization. But before that, to the blood subject should come. Okay, leave it now. Solve. Now remember, next class I will solve question number 83, 84, 85, maybe 86, 87, maybe. Total 5 more questions. 5 or 4 more questions. 4 or 5. There, I will decide now. If 5, see, suppose 88. If 6 more questions I am solving, 2 classes I will take. 3 questions. But remember, question, free body, brief explanation, answer. 1 more free body, answer. There I will get the answer. I will give the answer. Don't expect me every class to tell this is this way all. I will not tell. So go through that question number 75, master question for that relative friction. Then study 81 and 82. The 81, your wedge is moving right side. 81, wedge was past tense, moving right side. Now wedge is moving left side. Okay, sufficient information. Next classes, or 2 classes, I will close the friction, then I will start ladder friction. Okay. We will meet in next class. Thank you.